come to the precision part of the beer making process, and that's the brew process. What we have here is a burner. If your stove is powerful enough, you can use the stove inside. It does tend to stink up your house, especially when you add the hops though, so my wife personally prefers me to brew outside. So I bought this burner out here, and it does a more than adequate job. What we have right here is a 7.5 gallon brew pot with a spigot on the front of it. This is a stainless steel pot, and it is the way to go. If you're doing 5 gallon batches, it's perfect. It leaves just enough headspace. I'm personally not a big fan of brewing with a smaller pot and then cutting it with water later. The people that I know that do that tend to make a beer that has somewhat of a sour tinge. As we're brewing, there's going to be several parts of the brew process, and one of them is we're going to have to cool the wort really quickly at the end of the boil. And that is what we use this for, is a heat interchanger. We run cold water through the coil, which will be sitting inside of the brew pot, and that'll bring down the temperature of our wort to the temperature that we need to ferment it as quickly as we possibly can. And that's going to help keep your beer clear and very professional looking. Alright, what we have here is we have a Java Stout, stout style of beer that's brewed with coffee. You want to make sure once you get your kits that all of the stuff that is supposed to be in your kit is in your kit, and everything's ready to go. At this point, before we even start brewing, this is when you should activate your yeast. The way that you activate the yeast kits is there is a sack inside that has an activator that you have to find and then slam to break open. Once that's broken open, you mix it up throughout the kit and you let it sit for the time that you're brewing. Most of the kits require 5 gallons of water. I typically add about 5.5 gallons of water. That will help compensate for any of the remnants that you throw away after the brew. I actually take standard tap water. Some people are opposed to it. I have no problem with it. I like the tap water in my area here from Baltic, Connecticut. And I use a 1 gallon container, and I add 5.5 of these 1 gallon containers before I start my brew. As you can see, there's a fair amount of headspace in the pot, even with the 5.5 gallons. This will allow for us to catch it before it starts boiling over. As you can see, we've started our water boil. It's at this point that I like to add my steeping grains. The steeping grains are essential if you're doing an extract brew to give it that fresh taste. Steeping grains we're going to take out of this bag, we're going to put into a moistened bag, which is basically a bag made of cheesecloth that's going to allow the water to flow through it freely. We're going to take our steeping grains at this point, and we're going to add them to the boil. A lot of brewers feel that you should be adding your steeping grains around 165 degrees and keeping them there for about 30 minutes. I like to add my steeping grains as soon as I turn on the heat, and I'll remove the steeping grains when we get to 180 degrees. So I have to constantly monitor my water temperature at this point. Alright, we've reached 180 degrees. At this point, what we're going to do is we're going to remove our steeping grains. You don't want to keep your steeping grains in past the boil, because what will happen is you'll produce extra tannins and it'll give your beer an off flavor. So as soon as you get to 180 degrees, remove your steeping grains and get ready to add your malt extract. This kit that I've ordered comes with 6 pounds of dark malt extract. I like to add the malt extract as soon as I have taken out the steeping grains. So it's going to be somewhere between 180 and 212 degrees. You're going to want to stir consistently as you're adding the malt extract so that you don't burn it to the bottom of the pot. By the time you're done pouring this in there, your boil should have started. At that point, you're really going to start doing your documentation for when you should be adding your hops, when you should be adding a clarifier, when you should be adding your cooling coil. All of this stuff is really going to help you make a good beer. The 3 things that you really have to remember to make a good beer are precision, documentation, and sanitation. As long as you can do those 3 things, you're going to make a good beer. You have 2 types of hops when making beer. You have what's called a bittering hop that you keep in for a majority of the boil or all of the boil, and then you have what's called an aroma hop. It's that hop that gives you that hoppy smell and that hoppy taste when you grab the beer. If you didn't add any hops at all, of course your beer would be way too sweet. It would be disgustingly sweet. The hop's whole purpose is to counteract the sweetness of the extract that you put into the beer. This is a Challenger hop. It's a ½ ounce of Challenger hops. I'm going to be adding it to my boil at the start of the boil. That's going to be my mark for when my 60-minute boil starts. So I'm going to document that right now, and all other additives that I do or all of the corrections that I make throughout the boil will be according to this time right here, which is 6:05. Alright, we have reached the midpoint in our boil. At this point we will go ahead and add our cooler. All that I've done to it so far is rinsed it off. There's really no need to sterilize your wort cooler because, well, it's going to be sitting in boiling water for ½ an hour, so any sterilization that's going to be required is going to happen at that point. It is good to clean it off a little bit and make sure you're not getting any chunks in there. Other than that, just let it sit in the boil for ½ an hour and get ready to cool off when you're done. Alright, we have our wort cooler hooked up on one side to a garden hose, and what's going to happen is the garden hose is going to push cold water through the coil at the time when we're ready to cool our boil off, and it's going to expel through the other side down the well. Here it is at 7:03. We are adding our aroma hops for the last 2 minutes of the boil. They are Kegging hops, and here they go right in. Be very careful when you add hops. When you add the hops, that's your most likely point to get a boil over. So I brought the temperature down just a little bit, and this will be good for our last 2 minutes. And here we are at 7:05. We have turned the gas off. Our boil is done. At this point, we'll be turning on the cold water for the heat exchanger. And that's going to bring down the temperature of our boil as quickly as it can possibly be done. Our wort now is cooled down to about 70 to 75 degrees. At this point, we're going to be transferring it from our brew kettle to our fermentation vessel. A lot of people like to go with the primary fermentation and a secondary fermentation. A lot of people will go primary fermentation into a 5-gallon bucket and then they'll transfer it to a carboy after a week or two. I like to do all of my fermenting into carboys. I normally don't do a secondary fermentation. It's recommended for clarity of the beer and sometimes for flavor. This particular beer, I will be going to a secondary fermentation. I'm going to do a primary fermentation in this vessel for about 5 days. And because it is a Java stout, a coffee stout, what I'm going to be doing is transferring it after 5 days and adding the coffee to my secondary fermentation, where I'm going to let that sit for another week to 2 weeks. At this point, we're going to be transferring our wort into our fermentation vessel. At this point is where you're going to want to take your sample into your graduated cylinder for your initial gravity reading. Can you hold this, please? This is also the point where you're going to want to pitch your yeast. As you can see, this yeast package has started to swell, which is exactly what you want it to do. That means that the yeast is active and alive, and we should get some fermentation activity in this carboy within the next day or two, because we know we have active yeast. Pour it in as you're adding your wort to the carboy. That'll help get it to mix and spread up evenly. Just as we did with our final gravity reading, we're going to drop our hydrometer into our graduated cylinder, spinning it as we drop it. 1.045 initial gravity. As you can see, we've left a little bit of headspace in our fermentation vessel, and that's going to allow for the foaming up that happens naturally as a result of active fermentation, which hopefully, as I said before, will happen within the next couple of days. We're going to want to put our airlock on as quickly as we possibly can to avoid any possible contamination. And then we're going to want to give the carboy a good shake to help mix up the yeast that's inside of there. At this point, now that the brew is done and we have it into our carboy for primary fermentation, I bring it into a temperature controlled area. In this case, it happens to be my jam room. The most important thing about this place is that it is somewhat temperature stable and it's out of the sunlight. I set my carboy onto one of these pizza trays that's lined right now with paper towels, because I do expect this to overflow initially when the active fermentation starts. And this way, even though it overflows, this tray will be able to catch some of the overflow. We'll clean out our airlock, we'll put a new airlock on it, and we'll drive on. As a last step, what I like to do is I like to just take a piece of masking tape, mark the name of the beer, the brew date, and the initial gravity reading on the beer. And then if I happen to lose any of the information that I've jotted down in my notes, I'll at least have it on the outside of the carboy. And that is how you do 20 gallons of beer in 8 hours. I certainly couldn't have done this on my own. I'd like to thank my daughter and my other daughter, Wave, for being the camera person. The 4 beers that we did today will all be ready at various times. The 2 that we put into bottles aren't going to be ready for 2 to 3 weeks. The one that we put into the keg is going to be ready in about 3 days. This Java Stout right here, in about 4 or 5 days, is going to be ready to transfer to a secondary carboy, a secondary fermentation vessel, at which point we will add the coffee that will make it the Java Stout. It will be in secondary fermentation for another 2 weeks after that, and then we'll keg that one. And that one will be ready 3 days after that. So, all of them ready at various times, and sometime in between I'm sure I'll brew another beer so that we don't run out. In the meantime, cheers. Alright, what we have here is the Java Stout that we brewed yesterday. It's been in our carboy for about 12 hours, and as you can see, we are at the start of the active fermentation process. If you take a closer look at the airlock up here, you'll notice that we're getting a little bit of activity, and the CO2 that's being generated by the yeast inside of our mixture is breathing out, and it is escaping through our airlock, but because we have water in our airlock, that's not allowing anything to come back in. We have the start of a head of what's called caussin. It's the foam that appears on the top of your fermentation, and that is probably going to get so active that it might come out of our airlock. If you look at our thermometer here, which is a sticky thermometer that we put on the outside of our carboy, we're reading right around 76 degrees, which is the very high end of what we should be doing for ales. I would actually prefer it to be a little bit lower. I'd like to be fermenting around 68 degrees. It's just been a little bit warm out lately, so we're going to have to deal with what we get. What we're going to do is we're going to try to zoom up a little bit and hopefully be able to see some of these bubbles that are the product of our yeast eating sugar and breathing out carbon dioxide, which is ultimately what is going to carbonate our beer. If we were to not have an airlock on this, eventually what would happen would be that our carboy would explode because of the pressure that was built up on the inside. This is about 36 hours after the brew. You can see we have some very active fermentation going on, and what's happened is our airlock is becoming clogged. This can actually be a dangerous situation. It can overpressurize and blow off. So before I head off to work today, I'm going to go ahead and clean this area up and replace that with a clean airlock, and I'm probably going to have to do the exact same thing tonight when I get home.